Hey everybody, this is Larry. This is me going with Q4 of the recent weekly contest to 11 for Leetcode. Where I finished 35, I guess. But hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. It is a tricky problem, it's all math problem. And I think, to be honest, a lot of how I solved this, if you watch the video, which is right afterwards, I spent a lot of time just like staring at the screen, staring at the sky, staring up my ceiling, staring up pictures of people. I don't know. Well, I just kind of try to think about inspiration and how to solve this problem. And sometimes I'm going to talk a little bit about the thought process instead of just giving you the answer, because like anyone can look at an answer and be like, oh yeah, that makes sense. But this is my thought process. So my thought process was, to be honest, a lot of it was just thinking about similar problems. And I was thinking about prime decomposition in a lot of ways, and I was thinking about maybe pre-processing the queries or something like that. Queries. But looking at that n is equal to 10,000, I was like, okay. So yeah, and that building the full graph, if you just do 10,000 square, it's gonna be too much, right? So I was thinking about different problems like that, where you have GCD, because another way, they've worded it in a really funny way, but basically the answer is that if the GCD between two numbers is greater than threshold, strictly, I don't know why they do it this way, strictly greater than threshold, then the threshold, then there's an edge between them. So I was thinking about prime decomposition. I was trying to think about like similar problems where without the threshold you could be like, okay, well, like if the threshold is 1 where like it's greater than 1, well, you could do the prime factors of two numbers and then similar to that, right? So I was thinking along those ways, like for example, if your threshold is 1, all the even numbers will be together, and then all the multiple threes will be together, and so forth, and then you kind of merge them together in a way, because if 6 is in the threshold, then that means that you merge the 2 and the 3 components. There's a similar problem there. But that prime factorization of every number is going to be a little bit slow if we do it for every number, right? It's like n times square root of n or something, which for 10⁴ maybe is fast enough. I don't know. But I thought it would be too slow during the contest. So basically, the key thing to notice is just, to be honest, there's no... because as soon as... And if you watch the video, you see me like do a trigger real quickly, and the prerequisite for this problem is something called the prime cipher Eratosthenes. I'm just gonna call it the CIF because I cannot pronounce this very well clearly, but I gotta, every time I have to Google how to say this one correctly. But okay, but now that we have this, right, what does that mean? So the key thing to know from this CIF, at least for me, I don't know if this is in here, but the key thing to know for this one for me, which I actually did not know this for a while, or maybe I did know this for a while, but I wasn't sure in general, right? So wow, there's a lot of crazy stuff here, but the key thing to note is that the complexity of this is n log n, because basically if you do it from every prime and you do it naively, it's going to be O of n plus O of n over 2 plus O of n over 3 plus O of n over 4 plus ... right? So it turns out that if you sum this up, you get O of n log n or something like that, or I forget what it is. But yeah, because usually I write an optimized version, which doesn't really make sense in this problem. But once you kind of figure that out, yeah, once you convince yourself that this is, I think my form is a little bit off, but this is n of log n. So once you figure that out, then this becomes straightforward to do, because now what you want to do is just start it from the threshold, right? So now, how do you think about this in terms of graph, right? Well, two, this is a I can't English for this video. Connectivity problem, and for connectivity problem, there are a number of ways to do it. You could do by first search, you could do that first search. Union find is the other one, and the way that I do it is union find because we're going to do a lot of these queries. They're up to 10 to the 5th query, so we're going to do union find, right? And basically, we're literally looking at each divisor and going, okay, is this number, basically, instead of asking, okay, given two numbers A and B, what are their common divisors, right? So that's one way to do it. The other way to look about it from the CIF perspective is, let's get all the, let's say we have a divisor that is K. Let's get all the numbers that are multiples of K, right? So like we said earlier, here, we get all the even numbers and then we merge them together into one set in union find, right? We're going to get all the multiples of 3, put them together. Get multiples of 4, put them together. Get multiples of 5, put them together, and so forth. And once you kind of put all that, union find does a little bit of magic. That's the prerequisite for this problem as well as union find. I'm not going to go into that much details for union find because that's beyond the scope, but that's also a prereq for this problem for me. But basically now, as we said, we put them all in the same one super node, if you want to call it that. If two nodes are connected, they have one super node that is connected, right? And the transitive property holds here, right? If A is connected to B and B is connected to C, then A is connected to C, right? So from that, that's pretty much it. It's just trusting that this is fast enough. And I didn't always know this. I only learned this much later on. So once you kind of do this, well, for this problem, we have a threshold. And what does that mean? Well, instead of looking at it, we just don't construct because we ignore divisors of, let's say the threshold is 3 and higher, right? Or you only care about numbers that are 3 and higher. Well, that means that all the even numbers are no longer connected, right? So basically from that idea, we just start the threshold, or we start x from the threshold and plus 1 because it's strictly greater than. And then for every x in this case in my code, I connect every divisor together. And you could kind of do it by, like I said, because of, this is, you have some m square edges, but because, it's connected, all we have to do is connect it to the first node, which is x, right? Because if we have for example, even numbers, you could say, you have 2, 4, 6, 8, 10, and so forth. And then you could say the edges are 2 to the 4, 2 to the 6, 2 to the 8, 2 to the 10, and also 4 to the 6, 4 to the 8, and then ... right? But we don't have to care about these because of the transitive property that we just talked about, because we know that 4 is connected to 6 because 2 is connected to 4 and 2 is connected to 6. And that's how we just do the union straight up with the x. And once you do that, for each query, just do a union find query. You could talk about some math, but because of path compression, which I do, it's going to be, not adverse, but amortized over 1 eventually. You could do some math to kind of do that, but that means that for each query, there's going to be over 1-ish. It's a little bit higher than that, but let's say over 1-ish. You can look up inverse Ackermann function if you want. But yeah, so this is over 1 for each query, which is obviously going to be fast enough when 10 to the 5th. And this one, the pre-processing, is of n log n, which for n is equal to 10 to the 4th will be fast enough. Anyway, that's all I have for this problem. To be honest, as soon as I make that recognition, I was able to code it up. I mean, this is only 20 lines of code and not even, if you have libraries for this, you could have done this much quicker. Let me know what you think. Let me know what you like. And, join me on Discord. And you could watch me solve this live now. I was trying to be too clever. Trying to solve the different problem with the prefix, which is something that I do too much. Okay. Damn it. That was dumb. Okay. for don't the time I don't do it recursively too. Okay, focus. What is going on here? 1, 2, 2, if x and y share counter, so GCD is greater than some threshold. Okay. Okay. And then threshold. Okay. If n b sub I are connected. Huh? Oh. What is n? Okay. And I got 2 wrong answers. That's or maybe 3. I don't remember. That was silly. That's what happens when I do bottoms up. Okay, focus. Okay. This graph. I have some ideas, but I spent too much time on the other one. Threshold. strictly equated then. Okay, that's why. Hmm. Hmm. That would work. I guess. Whoops. Inclusive. Oh, I guess so. It doesn't really matter. Okay. Hey, thanks for watching this video. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord, and let me know what you think about this contest, this problem, and so forth. And I will see y'all next forum. Bye bye.